Good afternoon, everyone. I want to take a minute to go over the law of signs ambiguous case, which can be confusing at times for people, but I believe we will be able to help clear it up for you. And let me get my screen zoomed in to where you can see this and get a good focus. All right. So the law of signs ambiguous case has three different situations. All right. But they all center around when I'm given a side, and the adjacent angle. Side, side, angle. Side, side, angle. Side, side, angle. All right. But what we have to do when we're talking about the ambiguous case is we always have to calculate the height first, because the height is going to tell us whether we have one triangle possible, two triangles possible, or no triangle. So if I'm going to calculate the height on this triangle, I know that the sine of 30 is equal to the height over 16. So the sine of 30 is a half. 1/2 times 16 is 8. The height is 8. And in this case, this is the easy case, because the height, we're saying that this leg of this triangle is longer than the hypotenuse. Well, that is impossible, okay? 8 is bigger than 7. There is no triangle possible in this case. And again, we're not worried about this side over here. We're going to find the height, compare it to that one. If the height is bigger than this side that is opposite the given angle, there is no triangle like this possible. Let's look at this next situation. I kind of kept this easy. I'm using the sine of 30 always, and so that makes this speed up a little bit. The sine of 30, let's find the h value. We have to find the h value first. Is h over 16 again? The h value is once again 8. Now look, this time 8, the height is less than the hypotenuse. So that means there's either one triangle or two triangles. All right, one or two. So the way that I determine that is by comparing this height and the side that is opposite the given angle and the other given side. And in this case, 8 is less than this side that is opposite the given angle, and that side is less than the side that is adjacent to the angle. When we have that situation right there, there are two triangles possible. Okay, and so what we do is we need to start by solving the first triangle. So I know, using the law of sines, that 10 is to the sine of 30, as 16 is to this angle here. I'll call it angle B. Okay, the sine of B. And if I do my cross multiplying, I find out that the sine of B equals 0.8, and angle B, when I do second sine, is 53 degrees. All right, so now this angle right here is 53. And if I add these two together and subtract from 180, I can find out that this is 97 degrees. And I could find this last missing side by doing 10 is to the sine of 30 as C is to the sine of 97, all right? And I could find that last side. Now, how do I find the other triangle that's possible? Well, what I do is I take this angle that I just found, this 53, and I subtract it from 180. 180 minus 53 is 127 degrees, all right? And so now what I've effectively done is I have swung this side over here like this, and now my triangle looks like this approximately. I still use this 30-degree angle, but now this angle is 127. These two sides are still 16 and 10. All right. This third side, I just subtract, 127 plus 130, and I subtract that from 180, and I find out this angle is 23 degrees. And now I could do 10 is to the sine of 30 degrees, as C is to the sine of 23, and I could find this last side that I don't know. All right. So this is when there are two triangles possible. We like to call this the swinging leg because it could be like this, or I could draw it. It could swing over here like this, and the triangle could look like this triangle I have drawn. Let's look at the third possibility. So once again, let's find h first. The sine of 30 is h over 16. Again, I made this easy. H is going to be 8 again. So h is 8, and 8 is less than this hypotenuse over here, the side that is opposite the angle. But this side that is opposite the angle is bigger than the adjacent side this time. Notice up here, this side was smaller, so they've kind of flipped. All right. So when this side is bigger than the side that is adjacent to the given angle, and that is bigger than the height, there is only one triangle possible. Okay. And so now I can work through the law of sines. I know that 20 is to the sine of 30, as 16 is to the sine of B. If I do my calculations, I find I'm calling this angle B. I find out that angle B is 24 degrees, just using the calculator. All right. And so this is 24, which means this is 126 degrees. Okay. And now I could find side C by doing 20 is to the sine of 30, as side C is to the sine of 126. And I find out using my calculator, cross multiply, divide, and so forth, that C equals 32.4. So once again, three possibilities: no triangle possible, two triangles possible, or only one triangle possible, but they all center around this relationship between the height of the triangle and the side that is opposite the given angle and the adjacent side. When this height is bigger than this side opposite the given angle, there's no triangle possible. When this side that is given is less than the side opposite the given angle, there could be either two triangles or one triangle, and it depends upon this side right here. Since this side that is opposite the given angle is less than the other side, there are two triangles possible. But when this side that is opposite the given angle is the biggest, 20 is bigger than this side that's adjacent, which is bigger than the height, there's only one triangle possible. And hopefully that clears up what can be a very confusing situation for you with the law of sines today.